Welcome, my name is Alexander Boyd and this is an introduction to stone carving. First off, I'm going to talk a little bit about how you procure stone. So traditionally, the stone will be ordered from a quarry in a large slab that's called a scant. A scant is anything from a ton or bigger, so it could be 5 tons to up to 10 tons. These are large, raw blocks of stone that will then get sent to a primary processing center, and they'll be cut down on very large saws with blades ranging from this big to way taller than me. So once the stone has arrived at the primary processing center, like I said, it's going to be cut into smaller slabs, and these slabs will then go to a secondary processing area where they'll get cut down into something that looks like this guy here. So this piece of stone is sawn 6 sides slab, and it's sawn 6 sides because it's square on all 6 sides. So this is what myself, a banker mason, would receive in my workshop, and I would have been given a template such as this one. This is a very rudimentary template here, made of a Christmas card. And this is a basic molding called a cavetto, which I'm going to demonstrate cutting shortly. So the draftsman would supply the stonemasons with architectural moldings, such as this one. It's traditionally made out of zinc or plastic, or even card in some cases. And then we'd apply this to the stone to work the detail in there. Stone, being a natural material, has a lot of different uses. Everything from architectural cutting to aesthetic purposes to flooring to fireplaces. Really, you name it, you can make it out of stone. Traditionally it was used because it's hard wearing, sturdy, and it also looks beautiful, and it can be manipulated in many different ways. Stones come in all different types of hardnesses, softnesses, bedding types, colors. Really, the list is endless. So it's a very versatile material, and I think it's a shame that we're using it less and less nowadays. Has a lot of great uses.
With its uses, Alex,
yeah.
From a sustainability perspective, you can always repoint stuff.
You can, yeah. It's a material that kind of keeps on giving. You know, it's got a huge lifespan that even if it does have some repair work that needs doing, it's very easily treated. That's going to expand that lifespan.
Right. Typically, we'll bed them with mortar, and if we need to, we can go and it's very serviceable. We can replace the mortar.
Absolutely, you can replace individual units, and you can replace the mortar. You can carry out conservation repair work, crack repairs, and pin injections to just keep the material going. Yeah. We'll go on to tools next. So I don't know if you want to come in for a close-up, and I'll explain the different tools and what they do. So here we have a traditional mason's mallet. It's made of nylon with a wooden handle, and it's shaped round to get an even strike on the chisel as you work. So it just keeps things nice and even. After many years of use, these tend to look like apple cores. So you know, a real old school mason, his mallet will look like a total apple core. It's pretty cool. Here we just have some basic measuring instruments. Sinking square to check depths with. If you're working to certain depths, and we can check depths this way, and also just use as a general square for marking up. And then super basic again, refer to this as a straight edge, and this is for checking our molding when we work it, that it's nice and flat. We also have a square back here. Masons use all kinds of squares, carpenter squares, engineer squares. They all fit the bill and do the same job. Moving on to the chisels themselves. This is a pneumatic chisel. So it's pneumatic because this end of the shank here is shaped to use in a pneumatic gun. Traditionally, they used Caturi bottle guns were the main ones. These were made by Italian masons, and they're kind of shaped like a long cylinder, and different sizes, different shanks for different purposes. So smaller shanks would be for finer work, for detailed carving, and the larger shanks are for more rough work, like and heavier duty work. So the end of the chisel has a tungsten carbide tip, and this is how we're able to cut stone of all different hardnesses without our chisels exploding. So typically when we sharpen them, we want a nice even edge either side, so that every strike of the chisel is a nice even strike as we work the stone. There are two types of these ends here. One is the pneumatic and the other one is a traditional mallet head, which I don't have right now, but that's basically shaped with a little ball in the end, and it's meant to lessen the deterioration on your mallet. These mallets will last entire careers and more, so it's not really a big deal to use a pneumatic tool, although some purists may disagree. So I have two types of chisels here. I have this flat one, which is for working straightforward bits, some chamfers, some checks. And then I have these rounded chisels, which are called bullnose chisels. And these are rounded at the edges so that we can work profiles such as this one. And the rounded edges allows us to work curves, and they come in all different sizes too. So I have a slightly bigger one here if I'm working a bigger cavetto, and then I have a really small one for delicate work. Typically masons would have many chisels, probably 50 plus in a standard set, and they'd be all different shapes and sizes. I'll show you a different couple ones here. So here's a couple sizes of flat ones. And traditionally we're taught that whatever size the piece of stone that you're working is, you want to pick up the chisel that's closest to it. So say I had, for example, I'll draw it out on the top of the stone here for you. So here we have, this is the classic chamfer molding. You see this in a lot of traditional buildings, very basic molding. So for this one, I would want to select a chisel that fits just barely bigger than the size of the chamfer itself. So this chisel would probably be a good fit. I might go up a little bit bigger to like a 2-inch chisel. So that means that every even strike of the chisel, I'm getting an even strike closer to this line. Same thing for a cavetto molding, which we're going to actually, I can just demonstrate with this one here. So this guy, if we were to pick up this bullnose chisel, this might be a little bit too big and it might pinch in the corners. So we downsize to a slightly smaller chisel in order to get that nice even finish all the way through. That has one more tool here actually I'd like to show you. So this is a mason scribe. Scribes are used so that the pencil line stays in your stone. So if you've got a lot of lines and markings on a stone, you're likely to rub them off, or dust could rub them off eventually. So what you do is you take your scribe and you scribe your line in the top. That makes a small indentation. And then when you put your pencil line in there, the pencil line sits inside there and it won't get washed out or blown out with dust. So you're never going to lose your working lines. Just like a security aspect really of working. And some pieces can be very complex and you've got a lot of lines going on and you really don't want to lose them halfway working through the piece. I think we're going to just do a little bit of layout here. I'm going to lay out this cavetto molding. It's a very simple molding here, and then we'll work some stone. Okay, if you want to come around here, I'll show you this little marking out. So we're going to use our scribe on our template. We're going to mark it to the top and to the front here, and then scribe in the detail. That one's in there. Then I'm going to mark my points from where this comes. One on the top bed, one on the bottom bed. And to transfer those points, I'm just going to use my sinking square. I'll do a little what's called an ashlar stop over here. That's when the molding comes to a stop, and traditionally an ashlar stop would go into a wall or into the side of a building. And it would stop, and then the wall would continue up this way. So I'm going to make sure all my lines are scribed in. Another thing that the scribe does is it prevents any breakages from when we're cutting the stone. So if there wasn't a line that I've scribed in, because stone is a fairly free material, if my chisel was at the wrong angle or if it was blunt and I strike the stone could split. So the scribe gives you a point of indentation where the stone is more likely to break as well. So it can save you if your chisel's a bit blunt. There's not much more to say about the marking out, really. Okay, so I'm just going to sharpen my pencil on the top. Some people swear that they never do that on the stone. They tell me off. Some people have a little carborundum block next to their stone and they'll do this, but it's all going to get washed off anyway, so I just do it on the top of the stone. I have a mixture of a commercial and a classical background, so I saw the best of both worlds, from working things in a traditional manner to also working things in more of a contemporary modern manner with power tools and more efficient practices, and there's lots of shortcuts you can take to speed up the process of cutting stone. But for the purposes of this, I'll do it the traditional way. Alright, so we got us all marked in right now. And we're going to make some stone chips fly. So I'm going to start by just chopping in my stop here. I'm going to do this so that when I work the stone this way, I don't end up blowing this big corner out. When we're working stone, you really want to work from right to left. And it's good practice to always stop a little over halfway. You could probably get away with doing 70% in one direction, and this is because if I was working this molding all the way through and I carried on going this way, because stone's a free material, I could risk blowing this whole corner off. So you always want to stop when you get 60-70% of the way across and then come back the other way. So I'm going to stay away from my ashlar stop line for now. I've got this little relief cut in. Now when I work the material this way, I've got a little bit of a safety area, so I'm not going to blow off any corners. So I'm going to start by just knocking off the edge. On a bigger piece of molding, we'd use a pitching tool, which is basically a larger version of this, and we use a mash hammer, but for the purpose of this is quite a small mold, we can just use our regular chisel to knock the end off. So just one swift strike, that's removed a lot of the material in the end, and now I can start working in this profile on the end. I didn't have a chance to sharpen my chisels before today. So ideally I'd like a little bit of a sharper chisel. When the chisel gets a bit blunt, it's just easier to blow corners off when you're not getting a nice clean cut. Something worth looking at is when I'm working the stone, we're traditionally taught to approach at a 45-degree angle. This is so that the stone can kind of blow off to the side. You're not impacting straight into the stone this way, but you're giving the stone a chance to kind of peel away. This keeps things nice and consistent. So what I'm doing here is I'm establishing what's called a rough draft. Your rough draft is just freeing up a little bit of the material on the top and bottom. That's going to allow me to put in the central piece of the molding. Okay, so I got my 2 little rough drafts in on the end here. Now I'm going to switch to the bullnose chisel, and this is going to help me work out this central curve. If this was bigger, it was a bigger profile, I'd use a chisel called a punch with my mash hammer, and I'd rough out a lot of the material. But because this is a smaller one, we can kind of scale things down and use a smaller chisel. So I'm going to use a smaller bullnose, which is going to act as my punch right now. And the smaller the chisel, typically the easier it cuts through the stone. I'm just going to get rid of a little bit of this in here, make things a bit easier. My sharpest chisel here for these edges. Okay, so now we've got like the rough shape put in this line right tight to where my scribe line is, and this is going to set the profile for the rest of the stone to work through. So nice and gently I'm going to put in these edges. So now what I've done is I've put in my clean drafts. Now these are right tight to the line. Again, it's part of the process. So now I've got my top and bottoms in. I know these are right to the line. I don't have to take out any more material. And now I'm going to work between these 2 lines to give my final shape. Just like I worked my drafts in, I'm going to work the cavetto shape in a similar manner, using these lines. So my chisel will sit in these imaginary lines as I work the profile. So there'll be one down here, then I'll move my chisel up into the next one, into the next one. This helps keep things consistent, and then we'll be checking it with the straight edge later on. Traditionally, we're taught to work to 1 millimeter is our tolerance. So it's not a lot to play with, but after a lot of practice, it is possible. So now this is in. I'm going to rough out a bit more of this material here, and then that's going to allow us to continue working the molding. Use this guy. This might get a bit crazy. I thought this limestone was soft, but it's actually like it's pretty hard. It's the softest one I can get around here anyway. It's actually a Portuguese limestone. So this method I'm doing right now is kind of a more of a modern contemporary method. So traditionally, we'd chop in the rough drafts, top and bottom, and then you'd rough it out with your punch chisel here. But modern way, you'd probably take a grinder or a pneumatic gun and you just chamfer this out pretty close to the line, and then you'd cut your profile in. It's just a bit more efficient and a bit quicker. Yeah, and I guess after a few years, you get a sense of feeling for how the stone reacts, and you work a lot of different stones and different materials. You know exactly how hard to hit it, and what's going to happen when you do hit it, how the stone reacts, like I said. So yeah, it just comes with a bit of experience, and you do lose a lot of corners in your first year or two. It's only natural. In your first year, your first few months consisted of basically making flat surfaces. So I'd get a rough block like the ones I talked about earlier that come from the quarry. You get a kind of crazy rough block like this, and you get it dumped on your workstation, and they say, I want you to make this block into this here, so on 6 sides. So for months you just turn this into this first, flat, and then you do this side, and then you do this side, and so on and so forth until you've produced basically a cube or a rectangle. And what this does is it sets up what I was talking about before about the feel of the stone, and you do so much handwork working on these blocks that you develop a feel for how the stone's going to react. You get better chisel control with your angles, and just in general your efficiency goes up because it's very repetitive, and you do every stage many times. So you're really honing in your skills in your first few months when you're doing these flat surfaces. And after you've done the flat surfaces, you may just do something simple like the chamfer we were talking about earlier. It's just like this. This would be a basic drawn by a 3-year-old chamfer. So the stone would be like this. That's how it starts off. It's just a 45-degree angle down through. And then after that, you probably do an overlow, which is a quarter circle. And an overlow is just comprised of a couple of chamfers together. And then you move on to something like the cavetto. Some sweet slow-mo shots of this.
Yep.
Bits flying everywhere. Okay, probably roughed out enough that I'm happy to start cutting in the drafts again now. Just want to demonstrate here, I'm using my thumb to adjust the angle of the chisel or keep it consistent depending on what I'm working. So the thumb is usually the controller of our angles and our cutting. Some masons have their thumb on top, some masons have their thumb on the bottom. In the UK, I met a lot of northern masons that had their thumb on the top and a lot of southern masons that had their thumb on the bottom. So I don't know what that's about, but that's how it goes. The thing about stone is that you can't just go straight in and take out all your material at once. You have to work it back in layers. So it's a good patience builder for sure. If you don't have it when you start, you definitely will by the time you're finished. But it's pretty satisfying once you get the hang of it. Alright. Get in there. Knock out some of that middle now. In your apprenticeship, the apprentice master would want these lines to be perfectly straight too. Like every stage is calculated and precise, just to get in a good habit of working in perfect straight lines and angles. So my apprentice master's not here right now, so we're good. So we're probably at a point where we can start checking it with our straight edge. So we'll check our bottom draft first. And you can see a little bit of lights coming in at the end here. So we want to aim to get rid of that. So we're probably about 2 millimeters off right now. So what we can do is work from where we see that light down. And this is another thing that just comes with practice, is that you can see how much material has to come off. When you first start, it's hard to gauge what angle and how much material needs to come off. But after a while, you get a sense for, oh, this bit's high here, or this bit's low here. So going back to the flat surface thing, your apprentice master would make you check each stage with a big long straight edge. So when you rough out and you leave these little furrows in here, he'd make you put a straight edge on it and make sure it was straight from front to back. And then you would start finishing the surface, and each line of the finished surface he'd get you to check it with a straight edge, 1 millimeter precise each time. And if you went under, you had to start again and do another one. So you made sure you did it right and you took your time, and you just check so much. I can't overstate that anymore. It's just as much about checking than it is the working itself. So we can talk about that. We'll check this now. See, now we're pretty much perfect. I don't see any light coming underneath there. There's you could do maybe a 1/2 mil or less of extra fine work. That's not really relevant for the stuff that we do. We work to a millimeter. If we end up doing competitions, we do work to finer tolerances. So 1/2 millimeter or less would be the tolerance there. So they'll clean off, and we'll do the same with the top one. So in modern day masonry, traditional working techniques are being replaced by CNC machines and 6-axis arms that come in and do the work that I'm doing to take it to get to a millimeter in a fraction of the time. We need to keep these skills alive, because our heritage buildings are going to need repair work needing done on them, and a machine's not be able to go up on a scaffold and do these precise 1 millimeter treatments to our heritage buildings. And eventually, it's sad to say, but we don't want our heritage buildings phased out by glass and concrete and metal. It's important that we keep that history and that culture alive, and these traditional crafts are part of keeping that alive. This is just the final stage, so I'm just working down right to the finish edge. So we're taking off a very small amount of stone here, being very careful. We're probably taking 3 millimeters off max. The great thing about working limestone is that you don't have to sharpen your chisels nearly as often as when you work sandstone. When you work sandstone, it's like every 15 minutes you got to resharpen. You go through chisels really, really quickly. Back in the day, they would have a blacksmith at the end of the workshop, and they would be just constantly making chisels, sharpening chisels for the masons. Chisels had a constant supply. And you see a lot of interesting moldings that, using today's modern chisels, are really hard to replicate, because the blacksmith would have made very unique chisels to get in certain positions and angles that you can't do today. So pretty interesting stuff. Now we're looking pretty good. We're 1/2 mil, but we'll do the next little row here. So with a modern method of doing it, you'd have a pneumatic ergo, and you'd just kind of be peeling the stone off. It's a lot more efficient. That's kind of bridging the gap nowadays between the traditional hand tool working way and the more modern CNC or robot machinery working. There's still the traditional trade is alive and well in cathedral workshops. They work almost exclusively by hand and use very little power tools, whereas in commercial masonry, it's more common to use power tools, grinders, and pneumatic air chisels. But the same principles apply when you're using a pneumatic air chisel and a hand chisel. Almost there. Just going to chop this guy in the end. Just taking a bit of extra care at the end here to not be too heavy with the chisel and the mallet. Be a bit embarrassing if I blew the corner off. Yeah? I'll use this rasp for finishing, and I'm just gonna basically rub the stone, and this gets rid of any little high spots that might be remaining. A lot of buildings are traditionally finished just tooled, just straight off the chisel, so they wouldn't have had this luxury of getting rid of the high spots with the rasp. But
traditional wood carving was the same, Alex. They didn't have access to sandpaper.
they didn't, yeah.
But there's some research that they used to use fish skin, dried fish skin.
Fish skin, cool.
Into the philosophy and the art of carving.
So there we have it. Your classic traditional cavetto molding with a ashlar stop. Ready to be put on the wall.